Algebra 1, 8-8, differences of squares. So we're factoring. We're kind of going backwards from, or the reverse from earlier in this chapter. So we're going to do an example. We're going to just start with an example. I've got x squared minus 25. Okay, notice a couple things here with this one. If I were to have x squared plus bx plus c, if I was to look at this form, I'm missing the b. When that happens, that means b equals 0. So I add to get 0. So I don't want to overcomplicate this. I want you to see that x squared is a perfect square and 25 is a perfect square, and I have a negative here. So I'm going to write perfect square. And perfect square. Both of these terms are perfect squares. And here in the middle, I've got a minus sign or a negative minus. So here's our recipe for differences of squares. If these are both perfect squares and I have a negative in here, then my factored form is x minus 5, x plus 5. It's the square root of this one and the square root of this one, and I have a plus and I have a minus. And that's how we do this. So let's do another one, see if you can kind of get the hang of this. Let's do another one. Let's do x squared minus 49. Okay, so I've got a perfect square, and a negative, or a minus. So that means I just take the square root of x squared, that's x. That goes on the left. I take the square root of 49, that's 7. That goes on the right. One of these is positive, one of these is negative. Doesn't matter which one is which, just as long as one is negative and one is positive. And that's it. Now where it gets a little bit more tricky is when we start doing, well, let me give you a u-try first. Let's do a u-try, and then I'll get a little bit more tricky for you. Let's do x squared minus 36. So go ahead and factor that one, then we'll get a little bit more complicated. Okay, let's see how you did here. Perfect square, minus. So I can take the square root and plus 6, which is the square root of that one, and x minus 6. And there we go. X plus 6, x minus 6, difference of square. If I were to FOIL this out, I would end up with this binomial. Okay, now let's get a little bit more complicated. I've got 16h squared minus 9a squared. Ew. All right, that's okay though. Notice I've got a minus in the middle, which is what I want for a difference of squares. And if you look closely, you can see that each of these are a perfect square. 4h times 4h gives me 16h squared. 3a times 3a gives me 9a squared. So that means I can just say, okay, 4h plus 3a times 4h minus 3a. And I have factored this thing. Plus, minus, 4h times 4h is this, 3a times 3a is that, and I am good. If I wasn't sure, I could FOIL this out and see if I ended up with this same thing, and I should. So let's go ahead and have you do a few examples on your own. Let's have you do one more on your own, and then I want to do an example together. 121 minus 4b squared. All right, go ahead and factor that thing. Okay, let's see how you did here. I've got 11 is the square root of 121, and 2b is the square root of 4b squared. So I've got 11 minus 2b times 11 plus 2b. All right, and that'll work for that one. Now let's look at another one that is a little bit more complicated. 27g cubed minus 3g. Okay, now for this one, g cubed is not a perfect square, neither is 27, neither is 3g. None of this stuff are perfect squares. But if I do a little factoring, then I might see something different here. So if I look, I find the greatest common factor of both of these. I've got 3 and g here, and I've got a 3 in here in 27, and I've got a g here. So let's pull out a 3g. I'm going to factor out 3g. So 27 divided by 27g to the third divided by 3g, that gives me 9g squared minus 1. Because 3g divided by 3g is 1, and I've got that minus there. Now, I've got perfect square here. 3 times 3 is 9, g times g is g squared. 1 times 1 is 1. So I've got these perfect squares, and so I can factor this here. So 3g, keep that 3g out there, and then 3 times g plus 1 times 3 times g minus 1. And there is my factored form of that one. That one's pretty tricky, but there it is. Let's do, I think we're going to do 2 more here. Oh, we're going to do 3 more. Okay, we're going to do 3 more. Here we go. Another example. I'm going to do this one, and then you're going to do one on your own that's very similar. B to the 4th power minus 16. Okay, b to the 4th, that's a perfect square. B squared times b squared. And then 16, perfect square, that's 4. Okay, so I've got b squared plus 4, b squared minus 4. Okay, now when I get here, there's nothing more I can do to this one. But notice how this one is a perfect square minus perfect square. So I can factor this binomial even more. So I've got b squared plus 4. And then this would be b times b is b squared, plus 2, the square root of 4 is 2, times b minus 2. So I did the difference of squares 2 times for this binomial. And now I'm all done. I can't do anything else. Let's do, let's have you do one that's almost exactly the same as this one. Y to the 4th power minus 1. Okay, go ahead and do that one, and let's see how you did. Okay, I've got y squared minus 1 and y squared plus 1. If I FOIL that out, I should get this answer here. Now, this guy is stuck where it is because there's a plus here, but I've got a minus here, so that means I can still factor this one. 1 is the square root of 1, and y is the square root of y squared. So y plus 1, y minus 1 is the factorization of this binomial, and then there is no way to factor this y squared plus 1. And so that is your final answer for that one. Now let's go ahead and do one more example. And I've got y equals x squared minus 9 over x. And I want to find, I want to find the roots of this guy. And so what I'm going to do here is I'm going to plug in 0 for y. And then I have x squared minus 9 over 16. Why did we do a fraction? I don't know, but it's okay. So I've got a perfect square here, x squared, and I've got a perfect square here, 9 over 16. You might not notice that this is a perfect square, but let me show you. 3/4 times 3/4 equals 9/16. So 3/4 squared is 9/16. And then I have a minus here, so that means I can factor this, the difference of squares. 0 equals x plus 3/4 times x minus 3/4. And now I'm asked to solve this. I didn't write that on the top here, solve. Or find the roots, maybe is what it is, find the roots. So that's when I plug in 0 for y. And what we're doing here is we're finding the place on the coordinate plane where the graph crosses the x-axis. And we're about to do that. Remember how we do it when we get to this point here? We say x plus 3/4 equals 0, and x minus 3/4 equals 0. We subtract 3/4 from both sides, we add 3/4 to both sides on this one, and we end up with x equals positive 3/4 and x equals negative 3/4. So we'll just say negative 3/4 is here, and we'll say positive 3/4 is here, and our parabola is going to look like this. Those are our roots of this. So this would be, let's make the point here. This would be here. So this is the point, negative 3/4, 0, positive 3/4, 0. I think there's one on the homework that looks very, very similar to this. And that is the end of 8-8. Good luck on the homework.